Started. I'm showing my screen. Welcome everyone to the Local Agency Traffic Safety Academy. As always, quick introduction. My name is Anthony Schmaltz and Oliver. This is the email invitation that everyone receives. This is where the link to get here. A couple of important emails. You've got mine. If you have any technical questions or issues with downloading or accessing the webinars after the fact, questions about the upcoming topics or webinar, go to Dennis, our coordinator. You'll hear from him in a minute. And we also have a link to the Tampa Bay Traffic Safety webpage. Following that link takes you to our website that has information on upcoming webinars as well as the completed webinars. On that location, there is also a document library that has the files for all of the webinars that we've completed. These are downloadable. We have the PDFs of the presentations as well as the recordings. At the bottom of this, there is also the PDH request form for any professional engineers that are looking for continuing education. Those can also be found in the handouts of the pod for the webinar. With that, I'll hand it over to Dennis for the official Academy introduction.
Good morning. This is Dennis Falloon. I'm the District 7 Safety Academy Coordinator Consultant, and I'd like to welcome you to the 11th District 7 Safety Academy webinar for 2017. Today's webinar topic is Pedestrian Intersection and Lighting Retrofit by Humberto Castillo, Traffic Studies Engineer in Tallahassee, Florida. And he's got over 23 years of experience in both private and public sectors of transportation traffic industry in Florida, California, and Illinois. He has a Bachelor's of Science degree from the Clarkson University and a Master's in Business Administration from Indiana University. He's a registered professional engineer and also in Florida and a professional traffic operations engineer. I would like to mention to you that at the end of the webinar, we will be sending out a survey to you, and if you could please respond to that, I'd appreciate it. But now I'm going to just kind of give you an introduction to the Academy. Just so you know where you're at, this is the District 7 Local Agency Traffic Safety Academy. And this academy was put together and first started in 2013, and it was established to provide information on safety-related issues to enhance your local safety programs. Like I had mentioned, 2013, we're in the 5th year of it. It started in January 18, 2017 for this year. It'll on December 13, 2017. We have a window for our webinars, but they usually run between an hour and let's say 1.5 hours, because that's with Q&A. But the length of a webinar will depend on the complexity and the amount of content in that webinar. And these other two items I want to mention were just the link to register for the webinars and to also go to the Safety Academy webpage. And I also will mention too, when you do register, you get registered for all the webinars. As you can see here, we have all these webinars. So once you register once, you will get notification on all of these, and you just need to attend the ones that interest you. And like I said, today is October 4th, and it's pedestrian intersection and lighting retrofit. As Anthony mentioned earlier, which I'll tell you, that there are PE credits for this webinar, but there are also AI credits, which are submitted and through Tendo Oliver and ourselves to the webinar. And those folks that are AICP certified planners can get those credits. I wanted to mention also that I'm currently working on the 2018 FDOT District 7 Safety Academy topics, which will begin in 2018, and we're working to have that list published in December of 2017, and with the registration also. And I won't go in a lot of detail here, other than the fact that our PDHs for Florida's PEs on the current web login, you can see where the forms are at, or you can go to the website and get the forms to submit to Larry Hagan, and he takes care of it. If you have any questions or need any assistance, please let me know, call me, or send me an email. With that, I'm going to turn it over to Roberto and let him do his presentation.
Thank you very much, Dennis. It is my pleasure to be with you this morning, and I want to thank Dennis and Anthony, also District 7, Peter Schum, Rochelle, and Ron Chin, that they have been very instrumental in terms of our efforts for the retrofit lighting in District 7. Hopefully everybody can see my slides. The presentation probably will last about an hour and a half. I have a lot of material that I would like to share with you, but also I would like to give you the background in terms of how we came about this initiative and the main reasons and what are the expectations of the department in terms of addressing these nighttime pedestrian crashes that we have. Before we start with the presentation, I want to give credit to Chester Henson. He was our lighting engineer. Unfortunately, he passed away last year, but he was our mentor, and he worked initially on this lighting retrofits and developed most of the standards that we are implementing today. I am in traffic operations. Initially, I was in the roadway design. Now, Ed Cashman, he's our new roadway lighting engineer. So if you have any questions regarding this topic or whatever we are discussing, please contact him. So intersection lighting retrofit objectives, and although it might seem that this is a very simple topic, intersection lighting is something that is being considered right now. If you are traveling on the roadway, perhaps you might see that there's lighting maybe on one side or both sides of the roadway. And the initial idea about designing the lighting for the roadway is that you're going to be maximizing the space between poles. Of course, we know that we don't place a lighting pole in the middle of the intersection. Having said that, the intersection lighting is something brand new. It's not even part of the lighting manual that we have for Ashton, and they are coming up with new criteria. So the intersections, by design, they tend to be a little bit darker than the rest of the roadway, and that's where the pedestrians hopefully should be crossing using the crosswalks. So out of our analysis in terms of nighttime pedestrian crashes, we determined that intersections, we needed to lighted them just to make sure that we address the safety of the pedestrians. So we came up with this initiative. So just to begin, just to answer the 4 simple questions: the why, the what, the how, and the when. So looking through Florida, we have this crash analysis report system where we monitor all the type of crashes. So in terms of the nighttime pedestrian crashes, we saw an increasingly disproportionate number of nighttime pedestrian crashes. So we want to address that safety issue. If you are familiar with Division 0, and also with the Strategic Highway Safety Plan, Florida is a focus state, which it means that we have a high number of fatalities nationwide. I believe that we are in the second place with most state with most fatalities. That is something that we're not proud of, and we are making sure that we continue to implement all of these design innovative ideas to reduce that number. And we have as part of this lighting initiative is one of them. When the initial process, it was we did a prototype project when we selected 20 intersections. I will be talking a little bit more about those, and based on what we learned from those 20 intersections with high nighttime pedestrian crashes, with fatalities and severe injuries, then we use those 20 intersections as the basis for our statewide analysis. So that's why we identify intersections based on corridors and limits, and we will talk a little bit more about that. Sometimes the original approach was the squeaky wheel gets the grease, and we were just addressing hotspots, but sometimes it doesn't address the underlying problem that perhaps you might go ahead and address an intersection, and if you correct that one, you might be shifting the problem to adjacent intersections. So we want to have and to use a systematic approach. Also, in terms of the new technology, the lighting that it has been used in the past is the high pressure sodium, which it solves the issues. However, there are some challenges in terms of the technology, and that it takes time for the light to come up just as it is warming. And sometimes because of the kind of yellowish or reddish color, it doesn't give you as bright of a contrast if you were using the LED technology that is more in terms of the bluish, type of a cooler color. Also, addressing the need in terms of new construction and retrofitting of intersections. For new construction, you will go ahead and design it with all the new criteria on the 4 approaches. For the retrofit, we just see what existing conditions we have and see how we can go ahead and provide the best design within the existing conditions. So there are some challenges, but nonetheless, how we can go ahead and improve the lighting levels within the existing signalized intersection. That is also something that I want to mention. All of these intersections for the retrofits, there are existing signalized intersections. We have over 8,500 signalized intersections on the ON system. Out of those, we had identified 2,500 statewide in terms of our new lighting retrofit initiative. Also developing benefit to cost ratio. We know that funding is not unlimited. So based on the amount of funding that we were allocated for this project, how do we identify the corridors based on the distribution by districts? We have 7 districts within the state of Florida, and also we have the turnpike, but mostly we were addressing the intersections within the 7 districts. The distribution was for $100 million that it was allocated, and we will talk a little bit more about how that $100 million came about, and also both the design and the construction implementation. This is a 5-year initiative. We are currently in the design phase. Some of these projects, depending on how fast we can put them out to construction, or if they are part of some existing 3-year projects, we're going to be starting the construction phase. So that is in general what the PowerPoint presentation is going to be about. On this slide, we can see the top 20 intersections with the highest nighttime pedestrian crashes. What we did, if you are from Florida, we have District 4, 5, 6, and 7. These are within the urban corridors. You can see the Tampa area, the Orlando, the Miami, Fort Lauderdale. All of these urban areas, they're in high density areas where there is a lot of pedestrian crashes. We had identified 20 intersections. We collected data for 4 years from 2009 to 2013. And out of this, if you can look on the right-hand side, we have the total number of crashes. All of these, they are pedestrian crashes that happen within a 24-hour period over 4 years. However, if we were to break down the crashes, we see that out of these, probably between 70 to 80% of those crashes, they're going to be nighttime pedestrian crashes that we have. Between these crashes, we'll have injuries and we will have fatalities. So just based on the data that we had collected for these intersections, and we worked with each one of the districts, we had determined that these intersections, they had a significant number of crashes. Now, the definition of a crash is that it is a random factor. And if you are familiar with the Highway Safety Manual, if you were to divide in terms of intersection crashes, perhaps on a year-time basis, maybe you will get maybe 3/4 of a person crash, 0.75 to 1.5. So when we divide 11 crashes by 4, we know that we're getting more crashes than what is expected, and that there has to be something within the existing intersection that is more just than random crashes. So we concentrated on these intersections, and I will show you as we go through this one site why we needed to have the lighting. So some of the data that we had collected in terms of the distribution of the pedestrian crashes, this is for the year 2013. So total number of crashes for the year was over 8,000. Then we have the injuries and the fatalities. Now these are all pedestrian crashes. However, if you can see the distribution for the fatalities that we have between nighttime and the daytime, that 3/4 of the fatalities were happening during nighttime. So we know that lighting, intersection lighting, is something that we definitely have to consider if we want to reduce our fatalities. And this is not very expensive to do. However, it has to be done or thought about and implemented in a very systemic manner. So when we were talking about retrofits, the definition that we are giving the retrofits is that we have some existing signalized intersections. The majority of these corridors, they will have roadway lighting, but as I was mentioning it, the location of the lighting was pretty much away from the intersection. So we needed to concentrate in terms of how can we go ahead and provide lighting at the intersections. And it was not going to be a full intersection reconstruction, especially if you have the mast arms and you need to relocate them just to comply with the new lighting design standards. So let's do the best that we can, but have some minimum illumination levels. And that's what we came about with. So as part of these 20 intersections, working with each one of the districts, we can see some of the things on average that we consider that it was going to be the scope of work. And based on this average scope of work, then we came up with an estimated cost for this. Now, granted that this was, at that time, we were using the high pressure sodium, so it's a little bit cheaper than the LED. So based on our existing signalized intersections, we say on average, we will need to install 3 new light poles, with an estimated cost of $4,200. We will perhaps relocate a few poles. In some of them, we will relamp and rebalance the luminaires since they were the high pressure sodium. Maybe we have an existing pole that we can attach a tip luminaire. So just put some of the infrastructure, pull boxes, conduit, conductors, and the full cable distribution system. One of the assumptions was that because there was some existing lighting that we needed to have, we did not need to install a new power source, and we were connecting to the existing lighting source. So on average, it was $32,000 for this retrofit. Now we added a cost, a percentage for design for construction, and that was 20%. So on average, the cost for a retrofit of an existing signalized intersection, it was $40,000. Now granted, as we go through this, there are some special circumstances that it will be more, and we will be talking in more detail throughout the presentation, and in some there would be less. But we needed just to identify a cost so then we could come up with an average cost statewide. So in here you see our approach to this intersection. It was going to be very simple. We're going to be using some existing aerials, existing survey if we need it. As you can see, this is one of the intersections. You can see some of the symbology. If you see the yellow luminaire, it means that this is an existing lighting. Now this one is close to the intersection, but it doesn't provide the lighting illumination, especially where we wanted to have. So we have the Stair Road, and also we have Griffin Road. The blue legend is for the new lighting that we were providing. Now, if you can see, it says that we were attaching these luminaire tips to the existing poles. And these existing poles, it was based, this one was span wire signal installation. So we already had this strained concrete poles. So we were attaching the luminaires to these strained concrete poles, and that was the best that we could. We didn't install, as part of this project, any new poles. So then this was using the high pressure sodium. Also, I want to bring to your attention, if you can see the red dots and the dash and the dash lines, this is indicating where the pedestrians were crossing and where the crash happened. So as we know, sometimes pedestrians, they do tend to cross wherever they see a gap and not particularly using the existing crosswalks. So we do have crosswalks on all approaches. However, we see that the accidents, they happen away from the intersection. So one of the initiatives is that if there is better lighting where it can provide better contrast for pedestrians and vehicles traveling through the corridor, that the pedestrians will also be more inclined to use the existing crosswalk. So this is one of the intersections, and for the top 20, so we work with each one of the districts, and they provided similar design plans, and then they went to construction, either using push buttons, just internal contracts, and this was implemented. All of these 20 intersections, they were constructed at the end of 2014, the beginning of 2015. We have been collecting some data in terms of nighttime pedestrian crashes, and they have significantly been reduced. In some of them, we have not had any nighttime pedestrian crashes. So far, based on the before and the after data, we see a big improvement, and that's what we wanted to have. But this is just an example for you how we approach this initial top 20. So in terms of where we are right now for the lighting initiative, I just want to give you the chronology in terms of how we started. So in 2014, we had programmed the top 20, and still we were using the old technology, the high pressure sodium. Then in 2016, as many states are going towards LED, we knew that it was something that we wanted to do for several reasons. LED, and the technology is more reliable. We know that for the high pressure sodium, sometimes we needed to relamp every 6-7 years, and they're not as reliable in terms of the maintenance. So for a little bit of a higher price, and the price is dropping down with the technology as we advance in years, although it is a little bit more expensive, we noticed that we didn't need to change the LED luminaires maybe every 12 to 15 years. So in terms of the equipment lasting and being able to get a better return on investment, LED was much better. Also, in terms of the technology, that it provides a much brighter contrast, because the correlated color temperature, it tends to be more towards the bluish, kind of whitish color of light. So that is a significant improvement, especially you can notice it if you're using LEDs in your home, or if you are going through some roadway or intersections with LED. The other thing that we wanted to do, since intersection lighting for Florida, it was brand new, that we needed to have standards. In 2016, as we developed the LED, we needed to have standards both for new construction and for reconstruction. And there's a difference in terms of the illumination levels, but whether it is a reconstruction or new construction, as long as we improve the illumination levels, we know that we are going to be addressing those nighttime pedestrian crashes and reducing them in numbers. And that's something that we wanted to implement drastically. Also, as part of the 2016, talking with management, we got approved $100 million. This is an initiative that is supposed to be implemented within 3 to 5 years. Granted that the secretary said that he would like to accelerate the implementation of these retrofit intersection projects within the 3 years. So everybody's working, all the districts, very diligently, just to make sure that whatever mechanism we're using, whether working through internally through the districts or having consultants on board, we want to make sure that we put these projects out to construction as soon as possible. And then as part of the design, where do we go from here in terms of what we do? One of the other things that Florida has done is that for all interchanges, lighting, it is a must. So that is also part of the design standard. So we know that for a very low cost in terms of intersection lighting, we can have a significant return on our investment. If you have any questions, I know that I'm going to be taking questions towards the end, but if you can just be typing. So that was just in terms of the introduction, what prompted us to come up with this initiative, lighting initiative. Now I want to give you the background in terms of how we went from the top 20 intersections to come up to a statewide approach, because that was the idea. So let's learn from this pilot project that we had, and now let's go ahead and take those lessons learned and implement it statewide. If you can see, this is the map of Florida, and the gray areas is where we have our urbanized areas. So in the Panhandle, we have the Pensacola. In Tallahassee, that's where I live. Now the Jacksonville area, Northeast Florida, we have Palm Coast, we have Orlando, we have Tampa, we have Cape Coral, Naples, we have Port St. Lucie, Melbourne, West Palm Beach, and we have the Miami area. So all of these gray areas indicated that this is where we have the concentration of nighttime pedestrian crashes at existing signalized locations. So that was the first thing, identifying where the location of the problem is happening. We work with each one of the districts. They provided to us information. We had polygons, and we collected this data. We put it in the GIS map. We created shapefiles, and then based on this, we began this concerted, and I want to call it a systemic approach, how we're going to be addressing this in nighttime pedestrian crashes for signalized intersections. So here you see this is in the Dade, Broward County area. Each of the green diamonds that we have in here, they are pedestrian crashes. You can see that we have our roadway network and we have the counties. So all of this is within the urbanized boundary areas that we have. Now, as you can observe, we have within the roadway grid work, perhaps in some areas, you can see that most of the signalized intersections, they have nighttime pedestrian crashes, but in some of them, we do not have it. So I guess that the idea, what approach we're gonna be talking if we have a corridor that is a 6-lane divided, and you have, for the most part, dual left turn lanes, you have a right turn lane, at the intersections, you have bike lanes. And if you have a corridor that is maybe 10 miles, and the typical section, it is the same for the corridor. And if you have, let's say 25 to 30 signalized intersections, but based on your crash data collection, maybe out of those 25, you only have 15 that you have nighttime pedestrian crashes. So the question is, do we only address based on historical information and put lighting at the intersections that already have crashes that it has been determined based on historical numbers, or are we anticipating to have crashes also in the ones that we don't have anything up to this point in time? Now, let me bring you to this point, refresh your memory, that crashes are random. And the question that we ask ourselves, that not because there is not a crash at a particular intersection within this corridor today, it doesn't mean that perhaps there won't be a crash because the corridor, it is pretty much the same throughout all of these signalized intersections. So the idea for us, after several discussions that we had, was that we wanted to use the corridor approach, and that we will identify the beginning and the end, the limits within a particular corridor, and then all the signalized intersection within that corridor will be retrofitted with the lighting. So as you can see here, and this is a close-up of this. So for instance, this corridor, we do have some intersections with not. This corridor, it has some more. So we had all the information to make the determination where we wanted to go. So here, this is just a close-up in terms of this corridor. So here we have the corridors that we had highlighted, and the key was to identify the beginning and the end points of each corridor. Yeah, so we worked with the districts, we went back and forth, and based on these corridors that we had identified, then we began a systemic approach in terms of prioritizing these corridors, because depending on the amount of funding that we had, so in District 4 we had it in here, perhaps we don't have enough money at this time to address all the corridors. So based on the data that we had in terms of the crashes that we're going to be reducing or eliminating, then we proceeded to develop a benefit to cost analysis, which we will talk a little bit more. But this was the data that we used to develop the ranking of the system in terms of the benefit to cost analysis. So one of the things that it was challenging was in terms of, so how we're going to be distributing the money. At first, we were asking upper management that we needed to have $50 million. Granted that this initiative, it is the first that it has been done in a systemic approach using the highway safety manual in terms of our crash reduction factors. We use model number 4 using the crash modification factors in terms of nighttime pedestrian crashes. And initially we requested $50 million. Now the question was, how do we distribute this money amongst the districts? You know, we know that in certain districts that are more urban than others, but we wanted to be equitable. So after we had the initial 50 million, management said that they wanted to double that amount. So we came with $100 million. That was, so we had two variables that we could use in terms of prorating how we were going to be distributing the money. Initially, we were looking at the number of intersections. Now, if you are, let's say, for example, District 1 and District 3, they are more rural. If you have District 4 and you have District 6, 5, and even 7, they tend to be more on the urban side. So, of course, they're going to be having more intersections. But you might have several crashes within an intersection. So really the intersection was not a real representation in terms of addressing the number of crashes. So we discontinued that approach and we said, well, let's just go ahead and distribute based on the number of crashes that we had per district, based on the intersections or on the corridors that we had selected. So based on this, we had, if you compare the total number of crashes, was much higher than the number of intersections. And based on the number of crashes, then we did a proportionate rate, and then that's where the way that we divided the money for the funding. So there was a direct correlation between the funding and the crashes that were going to be, the number of crashes that were going to be treated. Now, in terms of the benefit to cost ratio, we had an estimation in terms of how much is the cost of a life to society. So for Florida is in the estimate of $11 million, to a severe injury, to a minor injury, to a property damage. So on average, it was over $1.5 million in terms of the benefit to society by reducing a crash on average. So our benefit to cost ratio, it was very high. If you use benefit to cost ratio in your district, your cities, in your states, you know that if something is above 2, it's worth considering. And for us, anything that it was in the order of this magnitude, you know, above 40 or within that range, we knew that we were going to be creating a dent into these nighttime pedestrian crashes. So management agree, and here we have a slide in terms of how the money was going to be utilized. So we had the $100 million. The 45% is actually the number of crashes that we were going to be addressing. So we concentrated on the corridors that had initially the highest number of nighttime pedestrian crashes. So if the cost was the same for each, on average, for each signalized intersection, but we were eliminating a greater number of nighttime pedestrian crashes, we knew that the benefit was going to be higher. So within the first $50 million, we were addressing 45% of the crashes. If we double the amount to 100 million, 72% of the nighttime crashes. As we continue increasing, we were treating intersections with a less number of crashes. So eventually, this number will taper. So $100 million, it has been a very ambitious project in terms of addressing safety, but we do have high expectations in terms of how we're going to be using. As I mentioned, it's 100 million over 3 to 5 years, but we have front-loaded the funding so we can use as much as this 100 million allocation within the first 3 years. So if you want to have, type some questions in terms of the distribution, the allocation, this is a good point for you to type your questions so we can address it. Now we're going to be focusing in terms of the lighting criteria for intersections. And initially, when in Florida we have our plans and preparation manual, it has been named like that forever, maybe for the last 15, 20 years. Now we're going to be changing this manual, and the new version is coming up at the end of November this year, and it's going to be effective in January 2018. It's going to be the Florida Design Manual. So some of this information is going to be migrating over to the new manual. So if you can see, we have on this table, the title or the heading is Signalized Intersection Lighting. Now, this is for new intersection lighting. If you have worked in lighting projects, you usually, for a roadway project on an arterial corridor, you will have your foot candle will be between 1 and 1.5. And that is something that you want to have, so which it means that the existing lighting within our corridors in Florida for arterials and collectors, which is not focusing on the intersection, the corridor lighting should be between 1 and 1.5. Now, for the intersection, we established a new criteria that for the horizontal illumination was going to be 3.0. So we are almost doubling or more than doubling in terms of the horizontal illumination. But also, we established a new criteria that is the vertical illumination. Is as simple as it reads. For the vertical, it's going to be what the driver can see as he is approaching the intersection. We want to make sure that the driver can see pedestrians when they are crossing the roadway at the crosswalk, hopefully. So we do have a 2.3 illumination. Now, some of this, it is based on the number of movements, and we're going to be discussing this a little bit. But in some instances, we know that this 2.3 foot candle design criteria is not going to be possible for all the movements. Then we have our illumination uniformity ratios, average to mean, and the max to mean. So this was for urbanized locations where we have a brand new intersection and reconstruction. I just want to make sure this is a brand new intersection or a full reconstruction of the intersection, that you're adding more lanes, you are relocating the crosswalks. If you have mass arms, you're relocating the mass arms. Whatever you are doing, that it is changing the alignment of the intersection. Therefore, the criteria is to put the lighting meeting the new design criteria. So just for your information in terms of where we place the location for the vertical illumination, if you can see, sometimes the lighting is not in the optimal location, and we're going to be looking at where the optimal location for the lighting poles should be within the intersection. But if the lighting is behind the pedestrian, as a driver is approaching the intersection, he or she might only see dark spots, silhouettes. So there's no color, there's no facial features or recognition. So sometimes it's very difficult to recognize a pedestrian. Even if there is no lighting at all, you know that, I mean, that's almost impossible. However, if the lighting, it is between the driver and the pedestrian, then we can say that there is positive contrast. And that's what we want. With the positive contrast, then we can recognize the pedestrian as he is entering the crosswalk. So the vertical illuminance is what the driver can see as the pedestrian is walking, and the horizontal is just as the driver is looking at the pavement markings, is just looking at the roadway. So the whole idea was that for the intersection lighting, we needed to have both vertical, horizontal illumination, which it has always been done, but also to provide the vertical illumination. So for the vertical illumination, we have three movements, and that as you are approaching, so if you are traveling northbound and this is your intersection, there are three movements that a driver is going to be making. One is going through the intersection. The second movement is making a right turn connecting to the side street of the intersection, and the third one is making a left turn. So based on the different type of movements, if we are going to be doing a brand new intersection with the new illumination design criteria, we will have to go ahead and to place lighting at all of these locations. So if you can see right here where we have the yellow highlight and the lighting pole, this is the driver, this is the pedestrian. So the optimal location is between the driver and the pedestrian. Right here, the location of this lighting pole on average is a luminaire mountain height, so it can be within 50 feet from the intersection. If the driver is making a right turn and you have a pedestrian that is crossing on the side street, this is the driver, so you want to put the lighting pole location at the center of the curb return. And this is illuminating towards the intersection, still making sure that there is a positive contrast. If you are a line resting here on the left turn lanes and you're going to be proceeding, theoretically, you want to make sure that you have the lighting pole between the driver and the pedestrian along the crosswalk. However, because of the restrictions or constrictions that we have within the intersection, there's not a perfect way that we can allocate and have a luminaire in between the pedestrian and the driver. So we go as close as possible. So we have a lighting pole that is also across in the radius return right here for the sidewalk. So this will be the optimal location. So that's why this left turn movement, sometimes we cannot achieve that 2.3 foot candle illumination, because this is the best location that we can place that additional lighting pole. So, on a base case scenario, based on your main roadway and your side roadway, at a minimum, you will need to have 8 poles that you have. So one is on the near side approach and also on the right turn approach. So if you put these two at every corner, also you are going to be addressing the left turn movement for the northbound on the opposite. However, in some intersections, since the vertical illumination is along the crossway all the way to the refuge or to the median island, depending on the width of the intersection, we might need to place an opposite lighting pole to make sure that we continue also increasing the illumination levels on the crosswalk. So this may require 3 lighting poles. So if we see on average, a minimum you might need 8, a maximum you might need to have 12 lighting poles to be able to address both the main and the minor roads to have your full horizontal and your vertical illumination levels. So the lighting retrofits design assumptions. So this was something that we had to come up with just to make sure. So we knew that because on existing conditions and the lighting, some of these corridors already they had lighting, that we needed to do the best that we could because we didn't have unlimited funding, and our estimated average cost was 50,000. So we increased the 40,000 to 15 by 20% because of the new technology, LED. So the assumptions were retrofits was going to be done for existing lighting at signalized intersections along corridors. The estimated average cost was 50,000 per intersection, and that included design, construction engineering and inspection, and the actual construction cost. That the luminaires will be LED. We, as part of this process, we develop new specs. We talked to several manufacturers. We talked to the industry because there is not a standard document, and states throughout the nation, they are developing their own specs right now. So for Florida, we develop our own set of specs. Not only that, we had to go through an approval product list process in terms of the various luminaires, whether it's going to be for a conventional lighting, for a high mass, for a sign lighting, or for underdeck lighting at bridges. So I was part of that process. It was very consuming. The conventional lighting poles that we have, I believe that we have, as of this moment, perhaps close to 16 to 17 manufacturers that they have been approved. So it was a very tedious process just working with the industry, but just making sure that the manufacturers were compliant with our requirements. In terms of the scope of work, it had to be simple, but at the same time effective. So the original scope of work, it can require all of those things or maybe some of this, but at a minimum, we just wanted to make sure that we address everything that we were accounting for, like installation of new poles, perhaps relocation of some existing lighting, maybe adding luminaires to existing poles, ancillary work, like installation of conduits, pole boxes, extension of the lighting circuits, and minor sidewalk reconstruction. I want to tell you that if sometimes when we talk about safety and we are at an intersection, we want to address all the safety issues that are part of the intersections. One of the things and the criteria that we wanted to make sure was that we understood that this 100 million was just for lighting, that if there were some ADA improvements, whether you needed to place a special emphasis crosswalk, or you needed to reconstruct the ramps to put the detectable warning systems, maybe to have accessible pedestrian signals, whatever it was, that the money came from a different pot and not from this $100 million, because we had identified 2,500 signalized intersections. We have over 8,500 statewide, and that the money, even the $100 million, it was only addressing 25% of all the signalized intersections. So we needed to be expedient and very deliberate in terms of how we're going to be using this money. Now, we could work, the district can go ahead and try to fund with a different mechanism as part of the project, and that was allowable. But this lighting funding, it had to be specifically for this purpose. So some of the other things, minor utility coordination, and we will look at, in some instances, where we have some overhead lines and some conflicts with the lighting poles, underground utilities, placing of the poles, maybe some utility conflicts. We were not expecting to have any utility relocation, whether overhead or underground, for the foundation of the lighting systems, just to use the lighting convention, not to use any shallow foundations, but just to use our cylinder concrete foundation. The other understanding was that there was existing lighting circuits, that these corridors already had roadway lighting, so we can tap into the existing lighting for the corridor and just make those connections. That voltage drop were going to be minimum, and no additional lighting disconnects or a power source was going to be required. Some of the modifications is in terms of the maintenance agreements, whether we have local agencies or we have utility agency owners. In Florida, the local agencies or the utility agencies, they are the ones that maintain our systems. So we just wanted to make sure that as part of the maintenance agreements, we do pay on average, I think that is $250 for maintenance and equipment upgrades, $250 per year per luminaire. I might be wrong on that, but part of that, 55% was going to be for me. Out of that, 55% of the cost was maintenance, and 45% was, well, 55% was labor, and the other 45% it was equipment maintenance. So with the new LED luminaires, we knew that the price is going to be changing. So we are working now with our municipalities just to make sure that as we are drafting the new maintenance agreements, that we're equitable in terms of when the luminaire systems are going to be replaced and how much money for the initial cost. So this has been also part of the process. So for the lighting retrofits, so we talk about new, now let's talk about retrofits. So for retrofits, it means that we have the existing signalized conditions, there's some lighting along the roadway, but we are going to provide some additional lighting. So for the horizontal illumination, we went from a 3.0 to a 1.5. So we reduced it in half, but still we know that the 1.5 is meeting the roadway illumination levels that we have for our existing roadways. So in essence, is that we just want to make sure that we comply and that we are providing something that is as good as what we have existing. So I will show you, we established the analysis of the lighting zones via polygons, and the illumination points were on a grid 5x5, and the perimeter was at the back of the sidewalks and the stop bars. But this is the criteria. So for the retrofits, it is relaxed. Also for the vertical, what I was showing before was that we were accounting for the three movements as a vehicle is approaching the intersection, the through, the right, and the left. So we decided that because the number of luminaires that is required for the three movements as part of the retrofit, it was going to be challenging, that our main concern was for the near side approach. So we decided also to relax the illumination level between 1 to 1 and 1.5, and not the 2.3 that we had for all the approaches. The grid spacing that we have is at the center of the crosswalk from the curb ramp all the way to the median, and the spacing horizontally is 1.65 feet with a 5-foot height. For all the approaches, use the near side, and that was the illumination level. So definitely making sure that at the very minimum, we are addressing as the vehicle is approaching the intersection. Once they are on the intersection, that the existing illumination levels will be adequate enough for right and left turn movements. The RDM, if you don't know, this is the acronym for the Roadway Design Memorandum. So this information, it was complementary to the information that we had in our plans preparation manual. Some of the things that we also were trying to point out is that all intersections will be different, that in some of them you may have some overhead lines, that your intersection for the pole placement, like if you see right here on this corner, this is a driveway within the radius or curve return that we have. So the optimal location of your pole for the near side approach, it might not be at the best location. So based on existing circumstances, that our goal was just try to be as consistent as possible, but to understand that also existing conditions will dictate for this side street. Apparently, this is some existing parking that is happening, so the optimal location perhaps might not be as we would like because of the existing conditions, and it has to be further away from the intersection. So that is the message that we were trying to tell designers, that just look at your intersection and work within the restrictions to make sure that it's based on engineering judgment. So for the horizontal illumination, as you can see, we have the perimeter for the horizontal illumination. A minimum, as we were saying, for the retrofit is that we will have, at the very minimum, 4 poles, and those are on the near side approaching. So 1, okay, excuse me. Let me go back. 1, 2, 3, and 4. So we went from minimum of 8 poles for a brand new intersection to a minimum of 4 poles. However, depending on the width of the actual major roadway or minor roadway, you might have to place an optional pole to make sure that you are lighting the intersection for the crosswalk. So we have the perimeter. We use AGI 34 software. So we just place this polygon and we say just calculate it based on a 5x5 grid within the polygon, and then we get our design calculations. For the vertical illumination, we will have a linear grid for each approach that we have, and we need to include some design criteria based on the traveling speed and the stop and sight distance. If you're traveling at 45 miles per hour, you need to be able, a driver at this location needs to be able to see a pedestrian crossing it, beginning to cross the, the intersection within the crosswalk, but also have the illumination levels at 1.5, minimum 1.0 foot candles. So we do it for all the approaches at each one of the crosswalks, and we will be looking at some of these examples. So some of the requirements that we have in the plan and preparation manual, so based on the design speed, and we assume that the design speed was the posted speed, or you can use the posted speed, you will have your traveling speeds, and then you will have your stop and sight distance, and you will input this into the AGI 32 software, and this will help you to develop your illumination levels for the linear grid. So, in summary, so what was the design intent? As part of this, we knew that the information that we provided in the plans preparation manual for new intersections, it was clear, but it wasn't as clear for retrofits. So as part of this process, we developed a training workshop to go to each one of the districts to convey this information, because it wasn't clear. And is we, as the robot designers coming up with these alternatives, sometimes had a hard time explaining the difference between a new intersection versus a reconstruction and the design criteria. We were asked by the districts, and we concur that it was best if we get all the people participating, not only from the DOT, all the internal engineers and the decision makers and the project managers, but also having the consultant work just to make sure that everybody was clear, because we needed to move along at a fast pace. We had $100 million and we needed to see progress. We needed to hit the pavement running, so to speak. So we didn't have a lot of time, once we began this process, just to clear a lot of questions that perhaps could have been addressed. So that's why we initiated the training program ahead of time, 2 or 3 months ahead of time, just to make sure that everybody was on the same page. So some of the design intent points that we wanted to convey was we did not want to have any relocation of any inlets, utilities, signal cabinets, driveways, or overhead signs. No purchase of right-of-way, because that is going to delay the project. Minimum of 4 light poles, at near side approaches for the intersection, and then perhaps a maximum of 8 light poles depending on the footprint of your intersection. And that was based on the geometry, the number of lanes, the throughs, the left turns, bike lane, right turns, so on and so forth. That at a very minimum, you will start your design having the light pole placement for the near side approach within 50 feet of the intersection, but of course that depends within the existing constraints, the roadway constraints, and that we wanted to have as much as possible try to achieve the 1.5 foot candle vertical illumination. However, we knew that sometimes it was going to be a little bit daunting just to meet the 1.5, so we decided that we could relax it to a bare minimum of 1.0 foot candles. The other thing was that our assumption was that in terms of the cost, we were going to be connecting to existing circuits. So we didn't have to incur the additional infrastructure costs, and that we will be coordinating with our maintaining agencies, discussing the luminaire types, the power, and the maintenance fee. So, and this is part of the existing and the continuous process that we have as we are moving towards the implementation of this initiative. So now this figure, just for your example, the roadway that is eliminated is the main line. So sometimes in our intersections, we will have an on system for DOT that this is the main line, and then we will have a municipality. So along the main line, we will have lighting within the roadway, but this was not placed strategically for intersection lighting. In the majority of our roadways, we only will have lighting on one side. On this one, we're showing lighting on both sides of the major roadway, but realistically, we only will have it on one side because we will have overhead utility lines on the opposite side. So if you can see, what this can tell us is that you have locations where you can see very well. However, the intersection is not as well lit as where you have the lighting. And in some instances, if you take away the lighting from the opposite side, some of the darkest places within a roadway lighting corridor will be at the intersection. And that is from a logic perspective, that was the intent. You wanted to maximize, if you want to have a roadway lighting system that it was very efficient and effective, you wanted to maximize the pole spacing. So it means that the locations of the poles for the roadway will be the farthest point for the intersection. With the new lighting, perhaps some of this will be in an optimum level. Some of them will have to be relocated, perhaps within 50 feet, that we need one within the radius return, and maybe we need an opposite pole. So when, based on the new intersection design criteria, the intersection levels, and also if you did not have any intersection, any lighting, any luminaires within the side street, we needed also to place it on the side street. So there was a lot of work. So for the retrofit, at a minimum, one lighting pole within each approach that we have, and at a maximum 8 lighting poles. So if you go to the DOT, the standard specifications we developed in section 992, and I do believe that we have the 2017 lighting specs that they are out, but there are several things that I want to highlight, that all the lighting luminaires that we're going to be used, they need to be approved as part of the APL, the product list, which it means that we have already worked with the manufacturer in terms of what we need to do, and they already submitted their products, and they meet every single requirement that we have within our spec. And there's a series of tests that will require, like the IES LM80 test. The driver should have 100,000 hours. It should be ready for 100,000 hours of operation. The circuit voltage was going to be 480. In terms of the luminaires, the surge protector should have been 10 kV, 10 kA, and also that we wanted to have a warranty, a protection for the entire luminaire, not just for the LEDs, but for the driver and for the surge protection of a 5-year. So that was critical, and several manufacturers, they needed to resubmit their paperwork more than once because they were not meeting our warranty requirement. So this was critical. Here you can see in terms of the correlated color temperature, that's 4,000. We are trying to go to a lesser correlated color temperature because of technology. So the 4,000 is more of the bluish. If you are reducing that temperature, you tend to go more into the orange. Also, we have for the roadway spacing, this is for roadway lighting, not for the intersections. We have increased this spacing. We talk about the AGI 32 optimization, and these are the roadway standards and what we needed to have as part of this requirement. So if you have some questions, you can go to our specification book, the section 992. Now, there are some instances where we do not have enough information on the specs, and this will require a technical special provisions. Part of that is when you have decorative lighting. Our specs was mainly for conventional lighting that we had for the standard cover lighting. But now if you had the specific for the decorative lighting systems, then you will go ahead and have to submit some additional information. So we talked to the districts and we provided the guidelines for a technical special provision. Of course, it's going to have to be reviewed by each district, but some of the minimum information that we require is that you provide some product information, the type of luminaires, the type of driver, making sure that all of these are complying and matching what we require in our specification book, the surge protection, the assembly, the warranty, the method of measurement, and the basis of payment. So this information will be submitted to the project manager, to the district project manager, and will go up the chain, will come to the central offices. And at this time, I believe that Ed Cashman, he's our lighting engineer, that he will review just to make sure that that what is being submitted as part of that project complies with the actual specs that we have. So this will be for the decorative lighting. Some of the things that you can see, this is a Hall of Fame. You can see this luminaire, this is the teardrop. What Hall of Fame did, which it was simple, they didn't have to replace the lighting arm or the actual housing, that the new LED was gonna be a kit system that it was gonna fit into the existing housing. So something very simple. They just needed to replace, plug and play, so to speak. So this was very helpful in terms of the decorative lighting. However, there are more than one vendor and there are many municipalities. So if you want to install the LED decorative lighting, you will have to go through this process, and just to make sure that you work with your manufacturer and the vendor. The other thing that we were talking in terms of the existing power sources, if these are some existing standards and we're just modifying based on the type of overhead or underground power system that we had a meter and we had a disconnect. So if this is connecting to an existing system, we didn't need to provide a new meter or disconnect system, just to make sure that we connected to the existing lighting circuit. So just as simple as that. All the designers, they needed to have as-builts of the power source and the existing connection. So that was part of their work. Now, in some instances, depending on if we did not have any lighting within the corridor, or if we had lighting, but we had a different maintaining agency, like the signals, because all of these are signalized intersections. If the signals are maintained by one agency and the lighting, the roadway lighting, is maintained by another agency, then we needed to have different connections and disconnects, but on this particular case, there was no roadway lighting on the corridor. So the question came about, well, do we need to provide a new power source, or can we use the existing power system, which is 120 volts for the signals, and just connect to that system using our proposed luminaires, the LEDs. So we came up with some standards, wherever you don't have existing roadway lighting, just to connect to the existing lighting signal system. How we're going to be having the breaker, the photo cell. So, and we provided these design standards. Excuse me. Let me just take a water break. So we have in here District 6, they also have their own standards. So as we started just looking at the different types of scenarios and working with the different districts, so we are combining and putting all of these criteria into the new PPM, which we're going to be developing very soon, but at least we have all the information available, at least the minimum requirements, so each district can go ahead and use this type of additional information. So here we are. So this is actually this is power line corridor. This is within District 4, and the name is very appropriate. But just looking at some of these things, this is a 6-line existing corridor that we have. We have some existing roadway lighting approaching on the main. Both of these corridors, they're major. You have power lines on one side, the roadway lighting on this side of the corridor. However, also you have power lines crossing the main corridor, which you have it on the side corridor. So you have the strain poles, a lot of overhead lines. We have underground utilities. The right-of-way line is at the back of the existing sidewalk. I don't believe that this sidewalk is more than 5 feet wide. So we are talking about a lot of challenges within the existing corridor in terms of the placing of the poles. How do we address the existing underground? Remember, 4 poles minimum on each approach, a maximum of 8. So if we need to provide an opposite lighting source, then we're going to be right here. We don't want to have any right-of-way. So on the very tight corridors, definitely there's a lot of challenges in terms of what we can do. And the other challenge that we had is that our standards for the luminaire poles, they were pretty much between 35 to 50 foot high. The upright of the pole, it was mostly 30 feet high, and depending on that, let me just go back to the slide. In some instances, we needed to go ahead and to have a special design for the lighting pole just to make sure that we are not hitting it, and there is a clearance that we must maintain. I think that is 10-foot minimum clearance with electrical power lines. So definitely we need to consider the overhead utility conflicts. We had some manufacturers that they had submitted different combinations for the upright of the luminaire as well as for the angle, for the mast arm, so on and so forth. So these are just some shop drawings submitted by 2 different manufacturers, Valmont and Hapco. So in our bulletin, and also coming up, so there were some variables that we needed to provide. So what is going to be the pole height? So this is the pole height. So we said that it can vary from 20 to 35 feet. So this is a variable that as part of your design, whenever you have a utility conflict, you must indicate in your plans. Also the arm length. This is the arm length. And this is the horizontal distance, and from the upright all the way to the center of the luminaire, and it will vary between 8 to 15 feet. Now, the pole height, okay, so we talk about the pole height, the mounting height. So the mounting height is this distance, is from the roadway surface, and this is from the edge of pavement. You have your traveling lane, and this is traveling lane, and this is the edge of pavement. So what is this mounting height? We want it to be 45 to 50 feet. So we're saying 30 feet to 50, depending, but for the roadway, most of our designs are going to be a minimum of 40, and we're talking about 50 feet. And also the arm height, I guess, yeah, this distance in here. So how much, and this is going to be based on the angle of the arm height and also on the length of the luminaire arm. So based on this information, we provide these variables to the contractor, and they will go ahead and design this luminaire for us, just to make sure that we are meeting our clearance from the utilities, overhead utilities. So this is a picture. This is a corridor that we have. This is a bike lane that is going onto the shoulder. So we have our clear zone. We didn't relocate any of these power lines. As you can see, it seems that this luminaire arm is as long or even longer than the upright. So very creative design, but we needed to do, we need to be innovative and inventive in terms of our approach, because relocating the power pole lines is a very expensive proposition. So we have it along this corridor, and based on this is in District 1. So we are using this model or this approach for our intersections utility conflict poles. So in terms of the contract negotiations, so we talk about some of the issues. So how do we approach this dealing with the districts? Most of these designs, on 75% of the cases, they're being designed by consultants. So we want to make sure that we provide all the information that is needed, but also that we do not go overboard. If there's whatever existing information, and we know the survey. So do we have an existing survey? Sometimes we say, well, what kind of aerials we can use? I know that in some instances, we use the imagery from Google Maps. It's not rectified, it comes at an angle, but if you can do some field measurement to complement the Google aerials, that is fine. If that works for you in terms of the scope of work, at the department, we also have in our survey section, we have the FDOT A+, and those are aerials that they have been rectified. They're very recent, and we continue updating them. You can use that information statewide. So if you are working for a municipality, you can download this, or you can use some new survey. So we are just going in the order of magnitude, just using as much of the existing information as possible. This is just the link to the website where you can get this information for the aerials. Utility coordination, and we know that that is critical. So at a minimum, whenever you had your plans developed, that you will submit that information just to confirm with the utilities that all underground and overhead utilities have been confirmed. Of course, overhead is much simpler than underground. But we could identify some of the undergrounds if we had, water valves, we had gas valves, we had sewer, force mains, so on and so forth, also for the water and for the storm drain. So just to make sure that we submit this information, we get some markups, because we do not want to, as we are perhaps doing some excavation or installing new pole foundations, to have a surprise that we're hitting, or we need to perhaps either relocate our proposed pole or perhaps a work for a utility coordination and relocation during construction. That is a no-no. So working with the maintaining agencies that we were talking, just to make sure that they had all the parts, all the materials and the labors, especially if they need to replace some of this arm length, that it was out of the ordinary just for the special mounting heights that we have for the utility conflict poles. So as part of the lighting analysis, we came up with some. If you are familiar with the process that we have in Florida, okay, so it's 11:24. Yeah. Yes, and we have 2 hours. I had some other things, but I just want to make sure that I go through some examples. I know that this is a lot of material. We had the lighting analysis, and we just wanted to come up with some number of hours, at least that we can estimate the cost. So as part of this, instead of having a full-blown design plans, we just wanted to have a report that is printed from the AGI 32. Some municipalities will use the visual professional. Yeah, I don't know if we provide the same report, but for the most part, this is what we use at the DOT. In terms of quantities, as you're establishing 1 to 4 hours, we estimated that there were going to be 2 submittals, a 60% set of plans and a final set of plans, 60% for review with the utilities internally, some correspondence with the utility coordination, and then of course part of that will include some field reviews and quality assurance, quality control, and some as-builts. In terms of the developing of the lighting plans, perhaps a key sheet. Remember that this was going to be a corridor approach, so if a consultant had a contract, there was going to be more than one intersection. So as many as whatever intersections were part of that corridor, and if there were several corridors within the contract to the consultant. The transport is the afterware in terms of how we identify the pay items and the quantities, general notes, plan sheets, 1 per intersection, and then traffic control. We have some standards sheets, standard index for the maintenance of traffic. However, if you needed to have something out of the ordinary, just to include that in the plans, and then supervision. So how did that come about? We indicated that on average, a negotiated fee per intersection. So if you had a corridor with 10 intersections, your design fee could be as low as $50,000, as high as $10,000. However, this is average, and we're giving a range. In some of them, that were less than the $5,000, especially if the utility companies were doing all the work and we were just providing just an schematic drawing. And in some other instances, there were more, and maybe double, 20,000. But that is the way that we estimated this cost, and that's what we use for our benefit to cost ratio. Okay, so this is a very good point in terms of the intent. So how we came about in terms of the initial 20 projects, we knew that based on science, that intersection lighting works, and we were going to be reducing the number of the nighttime pedestrian crashes. Now, based on those 20 projects, how we could go ahead and use that approach statewide. So that's why I'm also using the new technology, how we identify those intersections, those corridors, how we prioritize those corridors, because money is not sufficient. The $100 million only address 25% of all the existing signalized intersections. So based on that, the districts took their funding based on the allocation, and they identified their priority corridors, and they're working now, as we say. Some of them, they're finishing their first design projects, and they're going to construction. Some of them, they are working, so this is a continuous process for the next 3 years. We hope that within the next 3 years, all the intersections will be undergoing the construction and have it completed by by 2021, 2022. So I have 3 examples for you just to give you some idea in terms of how we approach these intersections. And Dennis, if you can let me know maybe 10 minutes before our hour, I can continue talking. I don't think that it's going to take that long, but just wanted to give you some idea how we approach, and these are some real life intersections. So the first one was in District 3. This is US 98 Arnold Road intersection. So here you have on this roadway existing conditions. As you see, there is no lighting at the intersection. There are some overhead lines and other underground utilities. The existing signalized intersection, the existing signals, there are mass arms, there are PET signals at the intersections, and they're all ADA compliant. Based on this, there are 2 gas stations, one gas station on the northeast corner, another one on the southeast corner. There's a business on the southwest corner. There's an IHOP. As you can see, in terms of the movements, for the US 98, pretty much you have, it varies in terms of the numbers of through. For the westbound, you have 2 throughs, 1 left turn. For the eastbound, you have 1 left turn, 2 throughs, but you also have a right turn lane. For the Arnold Road, you have a heavy left turn movement going southbound, 1 through. Also, you have a dedicated right turn slip lane. For the southbound, you also have 1 for the northbound. So conditions were very different in terms of what we needed to do. So in terms of the lighting poles and the illumination, both for the horizontal and for the vertical, was going to be critical. So this was a project that they needed to do a retrofit. They wanted to do a widening, provide a dual left turn for the westbound movement, but also they wanted to, yes, a dual left turn, but also they wanted to do a widening for the right turn. So they needed to realign the through lanes. In terms of these intersections, they also wanted to provide a triple left for the southbound. So this is the pay items. They had to relocate and put a brand new mass arm at the northeast, at the southeast corner. So part of this, so this was going to be the reconstruction, and also they wanted to provide lighting as part of this project. So this is some of the pictures, as you can see, for the eastbound. So they were going to be widening, providing a dual left turn. So they needed to relocate this right turn lane. Also, they were going to be relocating both of these mass arms. Also for this right turn lane, they're going to be relocating, as we were mentioned. This is for the side street northbound in Arnold. So a lot of conflicts in terms of this realignment of the lanes, access entrance to the gas stations and the driveways. So where was going to be the optimum location of the proposed lighting poles that we had. This is for the westbound. So there's an existing, so the lane configuration was going to be the same, but where do we place the pole? Do we have to provide it? Are we going to be impacting the existing driveways? Critical for the existing locations. And then this one is for the southbound. So we were providing an additional left turn lane. So how was this going to be impacting in terms of the overall luminaire placement? So as part of the intersection, this is a tentative design. I don't believe that this is the final outcome. So what we did was that instead of the minimum 4 poles, what we provided was 6 poles. So at the bare minimum, we know that we have 1 pole for each near side approach that we had, but also we had opposite poles. For us, we were not getting enough illumination for this crosswalk, so we had an opposite pole. And also for the width of these dual left turn lanes as part of the widening, providing that additional left turn lane. So we place another pole. This is your horizontal boundary for the horizontal illumination. And then these lines that you have for the crosswalks for each approach is for the vertical illumination. So after we did the calculation that we have, so for the horizontal, based on the number of poles and on the locations, the average was 1.78, which it was higher than the 1.5 minimum. So we achieved our illumination levels. And then for each one of the approaches, as you can see, it varied on average between almost 2 to 1.6. I mean, this one even was a 2.5. So it was very successful. There were other considerations or other variations of this design, but this is what we recommended based on the proposed relocations. This is what IGI 32 provides for you. So you have these printout tables, and you can use this also as part of your documentation. So something very simple that it will give you all your locations, your average, your max and minimum, your foot candle levels. Also, it will give you your coordinates and orientation with the height of the pole that you were proposing. So very in-depth and detailed. I have two more. In District 4, the Overseas Sombrero intersection. This is a very good one in terms of some conditions. The main highway is the Overseas, Sombrero is the side street. So this can be considered as a T intersection. However, you do have a driveway for a museum, which we needed to consider. There's a gas station on the southeast corner, Bank of America. There's 3 lanes traveling eastbound with a left turn lane. There is 2 lanes traveling westbound with a left turn lane, but also we do have a bike lane. So we have a bike lane, but also there is a multi-use trail as part of this. So it's very different circumstances. The multi-use trail is on the north side of the intersection, and you can have multiple users, whether people walking or on strollers or jogging, or bicyclists can use it, as well as other riders can drive on the bike lane. So conditions were there's only 2 existing crosswalks that we have. There's not a crosswalk on the westbound approach. So there's 3 crosswalks. So you are crossing the south leg, you are crossing the east leg, and you're crossing the north leg. So as part of the lighting, I also want to tell you that there is some intermittent lighting through the corridor. As you can see, these are lighting poles, and there is a lighting on this power pole, but there was not intersection lighting. So here you can see a lot of overhead lines. There's not lighting approach, overhead utilities, underground utilities. So something to consider. On the eastbound approach, there is some ambient lighting from the Bank of America. There is a luminaire tip and this power pole luminaire. No crosswalk approach, but there is no lighting luminaire pretty much on this side of the roadway. Some intermittent. There's a fire hydrant with the water main. Also, there's a force main. So a lot of issues in terms of utilities. In terms of the westbound approach, there's the existing roadway lighting. As you can see, 2 through lanes, the left turn lane, you have a bike lane, but also you have the multi-use trail. So this is an open drainage system, and this is the driveway that is used for the museum. In terms of the ADA improvements, as we said, part of the lighting retrofits did not account for ADA improvements. All of these approaches, they had the pedestrian push buttons, they had the detectable warning systems. Like this is a directional curb ramp. If you really wanted to make it full ADA compliance, they will go ahead and have, a dual access, not with the directional flare, but with the combined flare or separate crosswalks. But this was not part of this project. We have the pedestrian push buttons. So the type of luminaire that they were recommending was the ATBL. We use our analysis. I don't believe that this is the ultimate, but we provided an approach light in the, this is in the landscape area. This is the driveway entrance. So there was a landscape entrance. So we said, well, we can talk to the gas station owner and just do some landscaping modifications and provide a luminaire here. We just replace the tip on the westbound approach and change, don't provide a pole here, just put an LED, maybe relocate this pole to this location to be within the 50 feet and provide a brand new luminaire that it will serve this crosswalk. Yeah, there are many ways that we can scan this CAD, but this is what we recommended. This is our horizontal illumination grid. So based on this, so we have for the average illumination, we had 2.2, which it was much better than the 1.5 that we were requiring. So this one, it shows you the orientation and locations of the luminaires that we provided. Also, we used for the vertical illumination, the stop and sight distance, it was 45 miles per hour, 360 feet stop and sight distance. That information is input in your AGI. So this is some of the information that we had. So for the horizontal, actually this one says horizontal, but this is for the westbound approach. So we say that the average foot candle was 1.9, and you can see the different things. It goes from 1.4 to 2.5 then on average. So this is what we did for this intersection. And the last one, this one is in District 7, no, District 5. Well, do I have? Let me just go to District 7, I guess. We're not gonna have time. I just want to finish with District 7 with the slides. So pretty much in this presentation that I have, it has been modified. So I will submit this presentation to Dennis so he can update it. So this is last but not least, District 7. So this is Hillsborough Avenue and 56 on the intersection. So on this one, I just say Hillsborough Avenue and 56. So you have a lot of traffic on these intersections. Pretty much they are mirror image. So you have your right turn and slip lanes. At all of the approaches, you have dual lifts. All the approaches, you have 3 throughs, and then you have bike lanes. So definitely you have a special emphasis, crosswalks. This one you have your span wire signal. So there is a lot to consider. So based on our design criteria and on the width of the road, we knew that at a minimum, we will need to have 8 luminaires. The location of these luminaires will depend based on the conditions. So we don't have overhead power lines. We do have existing luminaires. As you see, we have the span wire signal diagonal assembly. So what is going to be the best locations for the proposed luminaires? Are we going to be using the existing signalized strain poles or not? So all of these things were part of the consideration. So this is the design that it came from District 7. So pretty much they decided that they were going to be placing that there was some existing lighting. So if you see the ones that they are solid luminaire, these are new poles. So at a minimum, they were placing poles in that they are within the radius return at each one of the corners. This is within the right turn lane, but also that we're going to be placing some new at the approaches. Like this is on the southbound, this is a brand new approach. However, you had some existing luminaires, like for the northbound approach, you had some existing luminaire right there by the crosswalk. I think that there's some existing luminaire that is not shown as part of this. So it just require 5 additional signals. They propose five additional luminaires as part of this new design, complemented by existing luminaires. So they proceeded and they calculated, they did their illumination calculations that they had for the crosswalk. So they had that for the intersection, on average, it was 1.6 what they had. And then for the vertical approaches, they had on the lowest for the northbound vertical approach, they had 1.4. But for the other approaches, they had higher than the 1.5. So overall, this was a very successful project. So I just wanted to give you a brief overview. We had 4 examples. We only could talk about 3. But if you have any questions at this time, I will be happy to answer the questions. I know that there's a lot of material to digest, but thank you very much.
Humberto, this is Dennis. Thank you so much. But I'm going to let Anthony kind of field the questions in the question box. If there's, I think of 3 or 4. Anthony?
Yeah, there's a couple of questions in there, and as we're talking, if the audience has anything else that they would like to have clarified, please feel free to type into the chat pod. Earlier on in the presentation, with regards to the lighting equipment, to enhance the lighting and the visibility of the pedestrians, will it be enhanced in the crosswalks or in corner areas, is the question that they're asking.
Yeah, and that is a very good point. As part of this project, our approach was just to make sure that we had the lighting, but any additional enhancements that each one of the districts determined, they could complement it with some additional funding. For instance, if you didn't have the special emphasis crosswalk, and the one that is special emphasis is the one with the ladder, so that it provides more visibility for drivers to see pedestrians. So if you didn't have it, you can go ahead and re-stripe it accordingly. So that one was one. Also, in terms of the pedestrian push buttons, some of them perhaps were not meeting the ADF requirement if they were too far from the curb ramps, and you needed to have a pedestrian push button to be within 5 feet of the curb ramps. You might have to need a separate pedestrian push pole, a pedestrian push button pole. So that one will have to be done perhaps within the same project, but with different funding. So yes, we were not precluding the district from determining what additional improvements needed to be as part of the intersection, but the money out of the $100 million, it had to be used specifically for lighting improvements.
Okay. Does the analysis, crash data, number of intersections in the inventory, etc., focus on intersections only involving state roads, or does it include all federally aid eligible roadways, including locally owned arterials?
Yeah, that is a very good question, because for us, we concentrated on on-system roadways. Granted that you could have 2 on-system roadways that they were crossing one another, or 1 on-system crossing an off-system roadway. So any of the intersections that were just off-system for the minor and for the major, we did not concentrate on those ones. But on any one that we were working with the municipalities for the minor roadway that was off-system, all the districts have been coordinated with them. But the idea is that even if municipalities want to use this approach on their system, that they will have an understanding how we did it, and that they can have a similar approach for the systems if they're all, off-system intersections.
Does the updated lighting design staff hour estimation guidelines account for new intersection analysis requirements?
Yes, I don't believe that the current one at this particular moment includes that. They might have developed a scope of work, or they are in the process. As I said, this is very fluid. The intent is that the scope of work and the man-hour estimates that we use to negotiate with consultants, that it will be updated. You do have it for new construction, because those hours already they have been estimated in terms of what you need to provide. But for retrofits, they will have to be modified. So I do recommend that if you are using the standard estimated hours spreadsheets that we're using, and it doesn't talk about the retrofits, that you will coordinate with your project manager just to make sure that you account for what is needed and don't go overboard in providing something that perhaps could have been submitted in a much simpler format.
Refreshing pavement markings and crosswalk visibility, is that kind of part of this effort, or we're talking strictly lighting?
Yes, it's only strictly lighting, and because sometimes we are not anticipating doing any resurfacing as part of that. So for the pavement markings, depending on how you are able to remove them, whether hydroblasting or if it is only for the pavement markings, it might not eliminate them completely unless you are doing a 3R, that is a milling and resurfacing. Some of the projects that they have been identified, they are part of a resurfacing program, the 3R program. So then the sanding and pavement marking will be accounted for along with the lighting, because this is a 3R project.
At the example for US 98 at Arnold Road, the max min was greater than 10. Is that okay?
And yeah, on that one, as I said, that one was just my first trial in terms, and that is a very good observation. So the max 10, maybe the same number of poles could have been used, but the placement of the intersections could have been changed, or maybe using a different luminaire. That is something that I did very quickly. So definitely that one was not I don't believe that was the ultimate design. And when I was provided that information, that was work in progress. But yes, for the max to min, if you are very close to the max to min, and we are talking about 10.1, 10.2, because this one's a retrofit. Remember that the foot candles that we were getting were 1.6. So if we get less than the if we are within the 1 to the 1.5, there's latitude, in terms of where we can place those poles.
That's the last question that we have there in the chat, but I always like to ask myself if there's any unintended consequences to the program. Switching over from the kind of amber lights to the LEDs. I mean, what have you? Any feedback? What have you heard back?
Well, that's still, this is something new. There are some municipalities that they are proceeding to convert to LED. We know that it has many benefits in terms of the contrast. That is a much better type of contrast. You can see colors better in terms of intersections. However, perhaps the lighting and the color temperature, it might be a little bit bright in some instances. So definitely there will be room for observation. If we need to reduce the foot candle illumination and don't need to be as bright, so as we address these intersections, we will continue making observations. And the other thing is, in terms of the technology, one of the things that we're considering is that for signalized intersections, that we will have, instead of having a permanent illumination, that we will have it at half level instead of being at 3.0 and 2.3, that we will have it at the 1.5 levels, for new intersections. And then as soon as there is a pedestrian call activation to cross the roadway, that automatically those levels will increase to tell drivers that there is something happening at the intersection. So we're looking at different options, how to use technology, get some feedback, but this is just brand new. So definitely we're using the design, beginnings of construction projects, but stay tuned and we will let you know. I'm sure that there will be more to talk about in the upcoming years.
Yeah, that'd be neat to have actuated lighting. Well, one observation, kind of like in the kind of unintended consequences arena that I know I've observed in the area, is that the older style lighting, it's less, non-LED lights are less directed, so they kind of spill out more.
Yes.
And you get the effect of lighting up the sidewalk in addition to lighting up the roadway. But when the LED lighting was installed in some of the corridors, they're pointed right at the roadway, and the LEDs are very directional, so they're lighting up the roadway perfectly. And now the sidewalk that used to be lit by the spillover lighting is now darker than it was.
Yes, you're absolutely right. Yes, yeah, you are correct, because you can direct the lighting. It's more of a focused beam because you have many LEDs and the angle is just directed straight. So yes, there is a much better distribution of the lighting, and we can avoid the unintended consequences of spillover lighting.
Yeah, but I mean, my point to that, though, is that was an unintended consequence of spillover lighting that was actually positive because the sidewalk was lit. So as a pedestrian walking along that roadway, you used to be lit, and now you're in the dark because the lighting was enhanced to the LED lighting. So that's, that there may be some corridors where you have high levels of pedestrian activity where lighting pointed back at the sidewalk to light it up, would be needed if you install LED lighting, is that you also need pedestrian level lighting, not just the roadway lighting.
Yeah, and it just all of these lightings, some of them they have some the backlighting, backwards, and just it depends in terms of how we block it or not. But yes, definitely we have more flexibility in terms of directing the lighting towards the road and within the same luminaire also to provide lighting towards the sidewalk, which is something that we want. Or if we provide separate lighting, maybe you have a multi-use path that is at the back of the right-of-way, and then we need some additional lighting for those. So as part of the analysis, we can go ahead and address all the lightings within the roadway, intersection, sidewalk, and perhaps some other facilities.
Do you have enough data that you've seen before and after? With the conversion to LED, or are crashes measurably going down or up, or are they staying the same?
Well, the only data that we have right now is for the 20 intersections, and they are for the high pressure sodium. For the LED, we're using the design and beginning of construction. So this time we don't have any after data, but we will make sure that we collect that, and we will let everybody know, what the findings are.
Is that?
Yeah, that's all the questions that I had. Let me see if anything else came in on the chat. We got a couple of excellent presentations. Thank you very much. Thanks for the excellent presentation to help the local agencies know the latest FDOT standards on intersection lighting designs. That's from Peter Hsu in District 7. So yeah, I mean, this was a lot of detail, Humberto. That was an interesting webinar. So thank you very much for your time.
Humberto, this is Dennis. I do want to thank you so much, and I'll share with you the survey results we get on this presentation, but it was very informative. So.
Very good. What I will do, Dennis and Anthony, I will go ahead and send you the latest presentation, because I do believe that what I sent you last week doesn't have some of the updated slides. So at least you can have the latest and greatest.
Okay.
Thank you. So anyone that downloaded the webinar or the presentation from the handout pod, because I did upload the webinar there, look for an updated one to be posted to the Tampa Bay Traffic Safety site. Again, follow the link in your invitation that got here that will take you to the Tampa Bay traffic safety site. So as soon as I get that from Umberto, we'll convert to PDF and upload to the presentation site.
Anthony, can we annotate that too, that it's updated? Just the word updated too? Yeah. Okay, cool. Very good.
All right, well, I guess that concludes this webinar. I'll go ahead and end the recording, and we'll stay on the line for a few minutes in case anything else comes in on the chat or we need to talk about anything else. Thanks, everyone, again, and thanks, Umberto, for your time.